Welcome, class. In this video, we're going to go over lesson 8.4, transforming quadratic functions. And specifically, we'll be going over the worksheets 8.4 mastery from our textbook. Now, just to review quadratic functions, I'm going to show you some differences here. Let's take a look. Here we go. Let's draw our basic quadratic function, y equals x squared. Y equals x squared. And we can see it over here on the right. Here's our basic parabola. It has a vertex at 0, 0. And let's see what happens when we change our quadratic functions. What if we put a 2 in front? What happens to the quadratic function? Well, we can see it here in blue. If you look at the graph here now, let me zoom in a little bit. The graph is actually narrower. The graph got narrower because it's growing faster in the y direction. Let's do another graph here. Let's do y equals 4x squared and see if it gets even narrower. Look, now we have it in green, and look at this graph. It's gotten more narrow. Now let's just compare some transformations here. What if we wanted to use a number less than 1 but greater than 0? Let's try y equals 1/2 x squared in purple. And if you look at the graph, that is actually the widest graph here. We have it, you can see it here in the purple. And what if the numbers get even smaller? Let's do y equals 1/4 x squared. And we can see it in black. So it looks like the graphs get narrower because they're growing faster. If we did a table of values, you would see that as you plug in points, like for instance, let's look at the red graph up here, y equals x squared. If I plug in 1 for x, we'll get the y value. If we plug in 1 for x, y equals 1 squared, which is 1. So the point is 1, 1. And we can see the red right here. We can see the point 1, 1 right here where the cursor is. Now let's look at another graph. Let's look at y equals 4x squared, the green one. If we plug in 1 for x, we get y equals 4 times 1 squared. 4 times 1 squared is 4. So the point is 1, 4. 1, 4, which is right here. So comparing the x graph here, the red graph, which is y equals x squared, compared to this y equals 4x squared graph, the y values are much greater by a factor of 4. Because these points here were actually stretched. If we take a basic parabola here, this red parabola, we actually stretched it to make it more narrow. And that's why it's going up faster now. That's an important concept. Now, I just want to show another concept. What if we took another parabola and we wanted to slide the parabola either up or down? This is called a vertical translation. So let's say we have y equals x squared minus 2. See the graph here? It's the same parabola. It's got the same width. It's not more narrow and it's not wider. It's the same width, but it's shifted down 2 spaces. The vertex before was 0, 0. Now it's 0, -2. Let's try another one. Y equals x squared minus 5. I have to zoom out here. Now the vertex, instead of being at 0, 0, whoops. Sorry, let me zoom in. I got to turn off the mouse pad here. Okay. Oh, it did not work. There we go. 0, 0. It's now 0, -5. Now let's see what else we have here. What if we have another graph of y equals? Let me do another let me do a reflection now. What if we have a negative graph? What would happen? Right now the graphs are positive x squareds and they open up. Let's make it negative. Y equals negative x squared. And now the graph is opening down. And all the same rules apply. If we put a -2, it gets narrower. Negative 4x squared, it becomes even more narrow. And if we did a y equals -1/2, it's going to get wider. -1/2 x squared in purple, it's now a wider graph compared to the green. And we can move the graphs up and down as well. What if I did y equals negative x squared? And we can do plus 2. As you can see this graph here now, let me zoom in. The green, the green graph right here was y equals negative x squared, and the graph in black is y equals negative x squared plus 2. It's shifted up 2 units. So now let's look at the assignment now. So it's just saying here, when the value of a in front of the x squared, and this is right here is written in standard form. We can see the quadratic right here, ax squared plus bx plus c is in standard form. Whether the a is in front of the x squared, or it could be written as the same a in front of the x squared here. This is also the same a value. When the absolute value, because the reason why we're taking an absolute value is if it was negative, the graph is opening down. We don't care if the graph is opening up or down right now. We're just checking to see if the graph is wider or narrower. When the absolute value of a is less than 1, the graph is wider. Example will be 1/2 x squared, and the graph looks really wide. When the absolute value of a, again, if it's negative, it just means it's opening down. If the absolute value of a is greater than 1, the graph gets narrower, like 2x squared, and the graph becomes real narrow. The negative sign just tells us whether it's opening up or whether it's opening down. That would be the same graph just opening down. And over here, sometimes we have it in standard form, or it could be even like this, x squared plus c form, when it looks like that. The c value just tells us whether the graph, if it's positive, the graph is shifting up, and if it's negative, it's shifting down. And that's what the table says here. We'll look at an example here. We have f of x equals x squared, which I'm gonna graph it here in this color right here. And then we can do another color, and I'll make this is going to be the other graph here, y equals 1/3 x squared. And see the 1/3 value here? It means the graph is going to be, oh, and I'm so sorry I made an error here because I couldn't, because I thought that was the standard graph here, because it's going to be wider. So this was the original. I apologize. There we go. There's the first one. And the red is going to be the wider graph, which is here. See, because it's 1/3. 1/3 makes the graph wider. Now, over here, we're going to compare the two graphs. F of x equals x squared. It's written very small, so it's kind of hard to see which is which here, but x squared is going to be this graph here, the one in the dotted line. And x squared minus 4, we'll do this one in red. It's going to be shifted down 4 units. So -1, -2, -3, -4. And there's that graph right there. So let's take a look now. It says compare the graphs of the functions below. Okay, f of x equals x squared. We could always make a simple table of values just to get a few points in, because this is really just y equals x squared. Let me change that here. Let me rewrite this so it's a little easier to read. If we plug in 0 for x, we will get 0 for y. If we plug in 1 for x, we'll get 1 squared for y. Y equals 1 squared, which is 1. If we plug in 2 for x, we'll get 4. So we can graph the point 0, 0, 1, 1, and 2, 4. And of course, there is a line of symmetry going through the center here. So there's going to be mirror image points over here. So I can draw here's the y equals x squared graph. Now let's do the other graph. And it should be remember it's a U-shape parabola. I'm writing on a screen that's vertical, so it's hard for me to draw some of the lines on here. Now the other equation is g of x equals x squared. which just means y equals x squared. Same thing. So if we make a little table of values, if we plug in 0 for x, we will get 0 for y. If we plug in 1 for x, I'm sorry, and I messed up the equation here. I just realized the values are going to be, I take that back. If you plug in 0 for x, we'll get 0 squared minus 4, which is minus 4. If we plug in 1 for x, 1 squared minus 4 is minus 3. If we plug in 2 for x, 2 squared is 4, 4 minus 4 is 0. So we have 0, negative 4, 1, negative 3, and 2, 0. And again, there will be mirror image across the line of symmetry. And there's the graph. So we have the two graphs, and the difference is one graph, I would say the g of x graph, is translated down. That's the proper term as we use the word translation. Is translated down 4 units. 4 units. It's 4 units below from 0, 0, the original point of the vertex. Now let's look at number 2. F of x equals x squared. Well, we can use the same table of values as we did before. 0, 0, 1, 1, and 2, 4. Again, a mirror image on the other side, across the line of symmetry. And of course, what happens here? Well, all the points are shifted up the same number. If we look over here on number 1, the points were all down. 0 became a negative 4, 1 here became a negative 3, a 4 became 0, because the graph was shifted down 4 units. In this case, we're going to be adding 5 to all the points. So if we take each point, we can just add 5 to it. I'm going to add 5. Add 5 to this point, it becomes 6. Add 5 to the 4, and it becomes 9. And I'm just going to do a mirror image. And here's this parabola. It's got the same width, but now this graph is up 5 units. And again, I know these are probably the worst parabolas you've ever seen. G of x is translated up 5 units. Up 5 units. 2, 3, 4, 5. Yeah, I'm just looking at 6. Yeah, I want to make sure the points were good. Now let's look at the next page. Here we're just comparing graphs by looking at the equations. Like if we look at this g of x graph right here, this g of x graph, if we look at the equation, it's 1/2, so it's wider. This means it's wider, and it's going to be down negative 3 units. And that's all it says here. It says we can move the points. It just talks about how the symmetry is still the same. Now this graph here at g of x, see the 3 is greater than the number 1 here in front of the x squared. So this graph will be more narrow because it's greater than 1. Remember, values between 0 and 1 are wider. And as a review of previous lessons, it says they were just finding the axis of symmetry here, x equals negative b over 2a. They're just confirming that they have the same axis of symmetry. Number 3. Now it says compare the graphs, and we can look at them. The original graph, let's see, is f of x, the dotted line. We're comparing that to g of x. So what do we notice about g of x? Look at the equation. It goes from 1x squared to 2x squared. So g of x is narrower, okay? It's narrower than f of x. It's also negative, which means it opens up or opens down. It opens down. And see the minus 1 right here? What happens if it's a minus 1? All the points are down 1 space. They all went down 1. And we call that a translation. So the graph is translated down 1 unit. Every point is. So that's the transformation of f of x graph to a g of x graph. That's how the graphs are similar, but there's some changes in there. And the transformation is really just describing the changes between two quadratic functions and really describing changes between any two equations. You could describe two linear equations, two quadratics, two cubic equations, two exponential functions. You could talk about their transformations. Number 4, compare the graphs without graphing. How's g of x different from f of x? Well, first I noticed there's a 1/4 in front. 1/4. Is a graph wider or narrower? Well, g of x will be wider. Excuse me. G of x is wider. We also have a +4 value. So is the graph up 4 or is it down 4? Well, it's going to be up 4. So it's translated up 4 units. And that's it. We just have to compare the functions. We just have to explain what g of x. F of x is the original function, so we're just comparing it. Now again, we're looking at h of x here compared to f of x. It's a negative. So what do we know about h of x? Is it opening up or opening down? You can say h of x opens down. Is it wider or is it narrower than f of x? H of x is narrower because 5 is greater than 1. The negative sign just tells us it's opening down instead of opening up. And lastly, the -1. That means it's translated. All the points are sliding either up or are they sliding down if it's -1. This -1 here. They are translated down 1 unit. And that's it. Now for transformations, we're using the word opening up and opening down. Opens down is not the proper terminology. Okay, opens down later will be termed as reflected across the x-axis, but that's going to come in later lessons in your higher math classes. We won't be saying opening up or opening down. We'll say it's reflected across the x-axis. That's the proper terms for that, and that'll come later in your math. So, well, this concludes this video lesson.